Welcome friends. In this session we will calculate fault MVA. If we have a transformer, for example, of a given MVA rating, and we know the voltage of HV and LV side, and we know the percentage impedance of transformer, so we can calculate how much fault current will be if there is a fault on LV side or if there is a fault on HV side. So we will do these calculations. So from where you can find these parameters? You can find these parameters from the nameplate of the transformer. So when there is a fault, phase to ground, phase to phase or three phase, the fault current will be limited by the impedance of a transformer, or if the NGR is connected, then it will be obviously limit further the current. So you can see here that 132 kV 11 transformer is the voltage rating. HV side is 132 and LV side voltage is 11 kV. Rating of the transformer is 26 MVA and the percentage impedance of the transformer is 20%. So now I wanted to know that if there is a fault on HV side, ground fault, then how much will be the fault current, and if there is a fault on LV side, then how much will be the fault current will be. So, and how much is the fault MVA? So fault MVA is basically the capacity of a transformer to create the fault current. So if the fault MVA is more, then the fault current will be more, and the percentage impedance, if the percentage impedance increase of the transformer, then the fault current will decrease, and similarly the fault MVA will also decrease. So SF fault is also decrease. This is very simple formula. So let's now calculate the rating fault MVA of this given transformer. Fault MVA can be calculated as MVA. We need to divide the MVA rating of a transformer divided the percentage impedance of transformer, which is 20%. If you convert it to per unit, it will be 0.2. So we'll divide this one by 0.2. So the fault MVA will be 130 MVA. So now we have calculated the fault MVA. Now we will calculate the fault current at HV and LV side. The formula that we will use is very simple. S is equal to under root 3 V into I. So I is equal to S divided by under root 3 into V. So if I know the parameters, so for HV side, I fault HV will be equal to S is equal to 130 divided by under root 3 divided by 132. So it will be 0.56861 kiloamperes. So this much current will flow on the HV side, and if you want to calculate the current on the LV side, the fault current, so you need to again multiply 130, you need to divide 130 MVA divided by under root 3 divided by 11 kV, so it will be 6.823 kilo amperes. So these are the rating fault levels for the transformer. So if you have a generator, for example, you can also find the fault current in the same way. You just need to divide the MVA capacity of generator by the fault level by the percentage impedance, and you can find out. So these are just an example. So we will you should know these calculations, an electrical engineer. So I hope you enjoy the lecture. Thank you very much.